Hello. Today we will be looking at Math 2144 Exam 1, Question 5. 9 points. So, what we're asked to do is give numeric values for each of the following using these assumptions up here, which you can read if you so desire. But we're going to go ahead and get started. The first one asks us to find the limit as x approaches 4 plus of f of x. What this means to do is we are going to follow the function from the right until we get to our 4 value. Note our x equals 4 is right here, and so we're going to follow that function from the right until we get to that. When we do that, we see we're going to follow this tail all the way till we get to 4, and we're going to reach that point, in which this case we are going to get 5. So with that, we're going to be able to answer this question as f of x equals 5, or the limit as x approaches 4 plus of f of x equals 5. Next, f prime of -8. So when we're given a graphical problem, f prime really tells us to be observing the tangent line. So what we're going to do is look at -8, which is going to be at x equals -8 rather, which is going to be right here. And we are going to observe its tangent line. When we observe its tangent line, we can see it looks something like this, as I've highlighted. Notice that it's flat, and when we have a flat tangent line, then we can conclude that the derivative is 0. And that tells us that f prime of -8 is 0. Next, limit as x approaches 2, or limit as x approaches -2 from the left of f of x. So, once again, what we're going to do is first find where our -2 is, which we can see that's right here. Let me highlight that in red. So, this minus means we're going to approach it from the left. So we're going to do something similar to the first problem, but we're just going to approach from the left, which means we're going to go from this curve, follow it until we get there to -2. And whenever we do that, we see that we end up stopping right here, which is also -2. Thus, -2 is our answer. Okay, next. Limit as delta x approaches 0 of f of 3 plus delta x minus f of 3 over delta x. So, if we see something looking like this, this should look familiar as the limit definition of the derivative. Oop, let me get my eraser. So just so you know that that is the limit definition of the derivative. Hold on, my bad. Just trying to erase this. There we go. So just so you know, that there is the limit definition of the derivative. Okay, back to pen. Great. So specifically, because we have this f of 3, we can say that this is the limit definition derivative at x equals 3. So what we're going to do is we are going to find x equals 3 in our graph here. And note, while we're not given exactly where x equals 3 is, we can definitely see that it's going to be somewhere between this 2 and 4, so it's going to be right here. So once again, when we're talking about the derivative, we're looking at the slope of a tangent line. Usually this might be kind of complicated, except for note that the tangent line at x equals 3 is going to be the same as the slope of this line right here. So all we need to do is just calculate this slope. To do that, we're going to note that from 2 to 4, we go up 1, 2, 3, 4, 5, and obviously going from 2 to 4 moves us 2 units to the right. So we went up 1, 2, 3, 4, 5, and we went over 2 units. And note that our equation for slope is rise over run. Thus, our answer is going to be 5 over 2. Great. And now that we have that, I'm going to go ahead and get rid of this x equals 3 thing right there. Awesome. So, now, limit as x approaches -6 of f of x. So, since -6 is right here, I'm going to go ahead and clean up some of the stuff that we've already used. So we've already looked at this. Oop, I erased the -6, but that's okay. I can recircle that. So, again, -6 is x equals -6 is right there. So notice that we don't have a plus or a minus in a superscript of a 6. So what we're asked to find is the full limit. Graphically, what the full limit means is we have to assess the limit from the left and the right. So what we're going to do is we're going to start by approaching from the left. Doing that, we're going to start here, follow it till we get to -6. And despite the fact that we have a hole there, we can see that the left-hand limit gets us 5. So I will go ahead and note that. Left-hand limit gets us 5. And we're going to do something similar for the right side, which I'll mark in this red pin here. Going to start here, and we're going to follow it until we get to 6. Notice that this full limit meets at the same point, and that point is 5. Thus, since the left-hand limit and the right-hand limit are the same, the full limit exists, and in this case, it is 5. Okay. Next, we are told to find df dx at x equals -5. Okay, so to do that, once again, remember when we're talking about derivatives, we are going to be discussing tangent lines. So let me go ahead. So we know that -5 is going to be between -6 and -4. So let me go ahead and clean up the stuff on this side so we can clearly look at that. Come on, work with me, please. So we're going to be looking right here. Notice, once again, that as we're looking at the tangent line at -5, it's on a line that appears to be linear. Thus, all we need to do is calculate the slope of this linear line. To do that, what we're going to do is notice that if we start here, we are going to go down 1, 2, 3, 4, 5, 6, 7. So we went down 7, so I'll denote that as -7. And we're going to go over 1, 2, 3, 4. Thus, we can zoom back out and note our slope is that -7 we went down divided by the 4 we went over. Thus, our answer is -7/4. All right. So, now, we are going to be looking at the limit as x approaches 2 of f of x minus f of 2 over x minus 2. So since we're looking at 2, I'm going to clean up this stuff over here. Awesome. So notice that this is also going to be another way to express that we're going to be talking about the derivative, specifically at 2. The way we can note that is because looking at this denominator here, whenever we get closer and closer to 2, this is going to go closer and closer to 0. So we can kind of assume that this was a delta x, similar to something we did here. Awesome. So, the way we're going to do this is, once again, we're going to look at the tangent line, except in this case, we're going to have to be very careful. Notice that before 2, it looks like the tangent line is decreasing. Notice that the tangent line here is some negative slope, continuing as such until we get to a 0. And when I say decreasing, I mean it's decreasing in magnitude. But anyways, from the left, that tangent line is looks to be about 0. But from the right, it looks like we would do something similar to these other tangent lines we've been doing when we just take their slope. And noting that this slope here is most definitely not 0, we can conclude that this answer here does not exist. We can also say that a sharp turn occurs. And if we ever have a sharp turn, then what we can say is that the derivative does not exist. Okay. Continuing on. As soon as I erase some of this stuff. Okay. Now we are asked to look at the limit as x approaches -2 from the left of the derivative of x. So, what we're going to note is now we are asked to find the limit of the derivative from the left, which is good because we have already done something similar. Notice that the derivative as we approach this -2, let me zoom in for you. This -2 here from the left is going to be the same as the slope of this line here, which we have already calculated when we were doing the derivative at -5. Thus, all we need to do is just write in our answer of -7/4. Awesome. Finally, one last question is to find the limit as x approaches 2. So this is a full limit once again, so we're going to need to look as we approach from the left and right. So when doing that, let's zoom in on our x equals 2 and approach from the left and right. So approaching from the left, we're going to start here, follow it till we get to 2, and we can see that we approach this 2. And note that the fact we have an open circle does not matter for our limits, because we're still approaching this 2 value here. Thus, as we approach from the left, we get 2. From the left is going to equal 2. Okay, let me erase that, and we will try the right side. Okay, once again, we're going to do the right side as soon as it will let me. Come on. Process. Awesome. So, from the right side, we're going to start here, follow it till we get to x equals 2. And what do you know? They're meeting at the same point, and it's that 2. Note, once again, we don't actually have a defined value there, but that's okay because we're just talking about what value it's approaching. It's a limit. So, what we can do is use that information to conclude that the left-hand limit and the right-hand limit are equal. Thus, the full limit exists, and we can confidently say that it's 2. Thank you for listening to this question. Good luck on your exam. I know you'll do great.
So the first question is asking about limits. And so what you need to do on this one is, one thing we notice is that as x goes to 3, that denominator is going to 0. And so since the denominator is going to 0, I can't just use my limit laws. What I have to do is do some modifications algebraically until I can get rid of that x minus 3 in the denominator. And so I can factor the numerator like this. I notice I can take a 2 out of everything, then I'm left with an x squared minus 9, which factors to x plus 3, x minus 3, over x minus 3. The x minus 3 over x minus 3 can divide to make 1. So this is just the limit as x goes to 3 of 2 times x plus 3, which is going to be 12. Notice that I continue to write the limit until I take the limit, and then I don't write the limit anymore once I have taken the limit. All right, so for the next one, so tangent is not defined at pi over 2, so we'll need to do some things to this algebraically. So I can say this is the limit as theta goes to pi over 2. I can write tangent as sine over cosine theta over, and then secant as 1 over cosine theta, which I can manipulate that. to be sine over cosine times, if I multiply by the reciprocal, and then the cosine over cosine can go away, and then this just becomes the limit as theta goes to pi over 2 of sine theta, which is equal to 1. For the last one, it says, suppose that f is a continuous function and that f of 2 equals 7. Evaluate the following limit. So if I know that f of 2 is 7, and I know it's a continuous function, I also know that the limit as x approaches 2 of f of x is equal to 7. Because the limit is equal to the function value. That's what it means to be continuous. So I can evaluate this using the limit laws. X cubed minus 4 f of x over x. So I can just evaluate this using my limit laws. So I can use the quotient law. Since the denominator is not going to 0, the bottom will be going to 2. X cubed will also be going to 2 cubed minus 4 times, and then f of x, as x goes to 2, is going to 7. So this just becomes 8 minus 28 over 2, which is going to be negative 20 over 2, which is going to be negative 10.
So then for our last one, it says, use the limit definition of derivative to show that d dx of 4 minus x squared is equal to negative 2x. But we have to use the limit definition, so we can't just go crazy and use power rule or whatever we know, right? So let's start by stating what the limit definition is. So if we remember, our limit definition states that limit as h approaches 0 for f of x plus h minus f of x all over h. So that's our limit definition of a derivative. So knowing that much, let's go ahead and work with what we got, right? So our f of x in this case is 4 minus x squared, okay? So if we have limit as h approaches 0 for f of x plus x minus h. So I'm just actually going to go ahead and plug in x plus h into this function. 4 minus x plus h squared, and then minus, or just f of x, so 4 minus x squared all over h. Okay, so now we have limit as h approaches 0 of, and I'm just going to basically FOIL this little thing out, right? Okay, so I will take 4 minus, and I'm FOILing this all out. So we have x squared plus 2xh plus h squared minus 4 plus x squared. So I just FOILed this, and I distributed this negative. Distribute this negative in there, right? And so then all of that's over h. Okay, so we have a limit h approaches 0 of, I'm going to just rewrite it by distributing this negative in here. So now minus x squared minus 2xh minus h squared minus 4 plus x squared all over h. So I noticed some things cancel out. So some things that I noticed right away are this 4 minus 4 cancel, and then this negative x squared and this positive x squared also cancel. So now I have something that looks like limit as h approaches 0 of negative 2xh minus h squared all over h. Okay, so from here I notice that the top has h in both terms, so I'm going to go ahead and just take an h out. So I know negative 2x and minus just 1h all over h, right? So then from here, this h and this h cancel each other, right? So now we're left with limit as h approaches 0 of negative 2x minus h. So we just plug in our 0 for h, and we are left with limit as h approaches 0 of this chunk that we were working with is negative 2x, which is in fact this negative 2x up here. So we know it checks out. Alrighty, thank y'all for watching this review. good luck on your exam, and continue watching our videos for exam prep every single time an exam's coming up. Thank you.